Alright, this is part 2 of our lesson 2 in Unit 1 on solving absolute value inequalities. Our objective in this lesson is to write, solve, and graph absolute value inequalities. This is our vocabulary. If you missed it last time, here's your second chance to write it down and get to know it. Alright, our mission in this lesson is going to be to solve an absolute value inequality that contains the absolute value symbols and the greater than or the greater than or equal to symbol. So an example of a problem that would look like this is x inside the absolute value bars is greater than 3. Solutions to these types of inequalities is all the values outside the interval -3 to 3 and was in between the interval -3 to 3. This one, greater than, is going to be outside. Less than was inside, greater than is outside. What this means is x, and that's supposed to be, is defined as x is less than -3 or x is greater than 3. So here's our first example we're going to work. We're going to solve, we're going to graph, we're going to write it in set builder and interval notation. Alright, one thing to know when we have absolute value bars and the greater symbol, greater than symbol, greater is or, less than is and, greater is or. So remember, first objective, nothing but the bars and what's inside of them on one side of the equal sign. So we have 2x plus 4 and it's all inside the absolute value bars. So what we need to do is we're going to take what's inside the bars and we're going to write it 2 times. We got a 2x plus 4 and we got a 2x plus 4. First time, everything outside the bars stays the same. Second time, everything outside the bars flips. Inequality changes direction, number changes sign. Now we're going to solve, whoops, and I almost forgot that it is an OR because it's greater than. It's an OR compound inequality. Now we're going to solve both inequalities. Multiplication, addition, get rid of your addition with subtraction. And you're left with 2x is greater than or equal to 2. Undo your multiplication with division. So x is greater than or equal to 1. Now we have to find our other answer. Let's see, we're going to follow the same steps. Since we wrote what's inside the bars twice, we follow the same steps to solve. So we're going to subtract 4. And we have 2x is less than or equal to -10. We're going to get rid of our multiplication with division. So we're going to have x is less than or equal to -5. So x is bigger than 1, or x has to be smaller than -5. What does that look like when we graph it on our number line? Right here, if I start at -5, 4, 3, 2, 1, 0, and then I come up to 1. What happens here is anything that is shaded for either answer. So I have x is greater than or equal to 1. So I have a solid dot at 1 and I'm shaded to the right. And everything that would be shaded for the second inequality, solid dot at -5 and shaded to the left. Everything that is shaded on either solution has to be shaded on your final answer. Interval notation, start point, comma, stop points. Alright, I'm going to put my negative infinity over this arrow, my positive infinity over this one. So what I'm looking for, I start shading at negative infinity and it stops at -5. -5 has a closed knot, so it has a bracket. Everything else has a parentheses. And it is OR between them. And I start up again at 1 and I go to positive infinity. Closed knot at 1, so it has a bracket. Everything else has a parentheses. And then finally for my set builder notation, I'm going to do my bracket, and it's for all real numbers x such that And then all I do is rewrite my solution. Alright, this is problem for you to try. I want you to remember that the one we started had the absolute value bars already by itself. This one does not. I have that multiplication of 3 out in front. So I have got to get rid of that 3. How can I undo that multiplication of 3? I must do this before I can write it 2 times. So think about that. Go about solving the problem and pause the video and work out the problem. Alright, so if you worked out the problem correctly, and hopefully I did too, you should get x is greater than 4 or x is less than negative 3. If I graph this on the number line, it looks like this. And shaded that way. My interval notation is start point, comma, stop point. Or starts up again here and goes on to here. That's my interval notation and my set builder notation for all real numbers x such that x is greater than 4 or x is less than negative 3. If you didn't get this answer, go back and see where you went wrong. Alright, this one is for you to try on your own, and I'm sure there'll be some type of question about it when you fill out your Google form. So, good luck. Alright, now think about this problem. This is an error analysis. What you see in yellow there is a problem that somebody did. And they wrote the solution. This is what they came up with. Well, they made an error. Where did they make that error? And I want you, on your Google form, you're going to describe that error and tell me how to correct that error. So good luck with that, and I'll see you tomorrow.